Hello, my name is Andrew Joe, and today I'll be teaching on how to find volumes by integration. In order to determine the volume of a given region, we can use one of the three following methods: disk method, washer method, or shell method. In order to figure out which method to use, we need to determine the axis of revolution and the region formed. If they are perpendicular, we use either the disk method or the washer method. If it's parallel, we use the shell method. Once we have determined that we need to use either the disk or the washer method, we need to then figure out if there is a hollow portion in the generated solid. This is usually caused by a region between two curves between some axes. If there is a hollow portion, we use the washer method. Otherwise, use the disk method. If the axis of revolution is horizontal, integrate with respect to x. If it's vertical, integrate with respect to y. The following is the formula for the disk method. Volume equals the integral of a as respect to x with domain from a to b, or b is equal to the integral of a with respect to y with domain of a to b, depending on the axis of revolution as mentioned in the previous slide, where a equals pi times r squared and r equals f of x or f of y, also depending on the axis of revolution. The limits of integration a and b works from the left to the right if integrated with respect to x, and from the bottom to the top if integrated with respect to y. If there is a hollow portion, then we use the washer method as discussed before. It's essentially an extension of the disk method discussed in the previous slide. We need to deal with a hollow object and two objects, so we have to use the difference of these functions. A equals pi times capital R squared minus lowercase r squared, where r or capital R is the outer radius and lowercase r is the inner radius in respect to the axis of revolution. The volume of a solid generated between f of x and g of x bound by vertical lines x equals a and x equals b, which is revolved around the x-axis, is pi times absolute of f of x squared minus g of x squared integral with respect to x with domain a to b. The volume of a solid generated between f of y and g of y bound by the horizontal lines y equals a and y equals b, which is revolved around the y-axis, is pi times integral of absolute f of y squared minus g of y squared with respect to y with domain a to b, where a and b limits are found by working from the left to the right if integrated with respect to x, and by working from the bottom to the top of the solid if integrated with respect to y. The shell method is the last method that we will be discussing about today. If the axis of revolution is vertical, integrate with respect to x. If it's horizontal, integrate with respect to y. Volume equals integral of length times height times thickness, or integral of 2 pi times radius times height times thickness. The volume of the solid generated by a region bound by the vertical axis x equals a and x equals b, which is revolved around the y-axis, is volume equals 2 pi times integral of x f of x with respect to x with domain a to b and radius r equals x. The volume of the solid generated by a region bound by the vertical axis x equals a and x equals b, which is revolved around the y-axis, is 2 pi times integral of x times f of y with respect to y with domain a to b and radius r equals y. If the axis of revolution is not the axis, say x or y equals c, then 2 pi times integral of c minus x times f of x with respect to x with domain a to b, or 2 pi times integral of c minus y times f of y with respect to y with domain A to B respectively. If C is less than or equal to A, then radius of shell is x minus C or y minus C respectively. If C is greater than A, then radius of shell is C minus X or C minus Y respectively. Thank you for taking your time to listen to this presentation.